Imagine waking up one morning, opening your window, and seeing nothing but fiery skies, molten rock, and a world that looks more like a scene from a sci-fi movie than the blue planet we know today. That was Earth over 4.5 billion years ago. No oceans, no trees, no animals. Just chaos. And out of that chaos, the world we call home began to take shape. Let's rewind time to the very beginning. Our story starts about 4.5 billion years ago, when a massive cloud of gas and dust swirled around the young sun. This wasn't a calm, pretty cloud, it was violent, filled with collisions of rocks and metal. Over millions of years, gravity pulled those pieces together, slamming them into one another until a huge, molten ball formed. That ball became Earth, but the Earth of those early days wasn't the solid ground you're standing on now. It was a hellish place, lava oceans, constant asteroid impacts, and poisonous gases filling the skies. Scientists call this the Hadean Aeon, and it lived up to its name. Hades, after all, means the underworld. One of the most dramatic moments in Earth's birth was the giant impact theory when a Mars-sized planet called Theia crashed into Earth. The collision was so powerful it blasted a huge chunk of Earth into space. Over time, that debris came together to form something we see every single night, the moon. That's right, every time you look at the moon, you're looking at the scar of Earth's violent beginnings. As Earth cooled, things started to change. Steam and water vapor from volcanic eruptions filled the atmosphere. Eventually, that vapor condensed, creating the first rainstorms. Imagine rain falling for millions of years, filling up giant basins until the first oceans were born. But those oceans didn't look anything like the clear blue waters of the Caribbean. They were dark, hot, and filled with minerals and chemicals. Still, they were the perfect recipe for something extraordinary, life before life. Though Earth had to go through another transformation, building its first continents. At first, Earth's surface was covered with molten rock that slowly cooled into a thin crust. But this crust was fragile. Beneath it, molten magma bubbled and pushed, breaking the crust apart and creating huge landmasses that floated on the surface. These early landmasses weren't like today's continents. They were small, scattered, and constantly changing shape. Scientists believe the first continent-like pieces of land appeared around 4 billion years ago, made mostly of granite rock. One of the earliest supercontinents we know about was called Vaalbara, which formed about 3 billion years ago. Over hundreds of millions of years, continents would collide and break apart again and again, giving us new ones like your Kennerland and later the famous Pangaea. Each time they broke apart and came back together, Earth's surface changed, new mountains, oceans, and ecosystems appeared. And each of those changes would eventually shape the path of life on our planet. Now here's where things get really interesting. Those first continents and oceans weren't just random rocks and water. They created environments where chemistry could do its magic. Think of shallow pools along volcanic coasts, rich in minerals and warmed by heat. Lightning storms crackling above, volcanic gases bubbling below. It's in places like this that scientists believe the first simple molecules of life, things like amino acids, formed. From there, it was only a matter of time before those molecules organized into something more complex, the first cells, of course. None of this would have happened if Earth's atmosphere stayed the same as it was at the beginning. Early Earth's air was toxic to humans, filled with methane, carbon dioxide, and ammonia, but over time, tiny life forms, microbes, began to appear, and some of them figured out a way to use sunlight to create energy. In the process, they released oxygen. This was the beginning of what's called the Great Oxidation Event, which changed Earth's air forever and made it possible for more complex life to exist. In other words, if those microbes hadn't started pumping oxygen into the air, you and I wouldn't be here today. Now, you might be wondering, why should we care about something that happened billions of years ago? Because the story of Earth's formation isn't just some ancient tale. It's the foundation of everything, the moon that lights our night sky, born from that violent impact. The continents we live on, formed from those first granite landmasses. The air we breathe, the oceans we swim in, even the life in our bodies, all of it connects back to those fiery, chaotic days when Earth was just getting started. It also reminds us of something powerful. Life came out of chaos. Our planet turned destruction into creation, and out of that came the world we call home, and this is only the beginning. Earth's story doesn't stop with the first continents. Next comes the rise of animals, dinosaurs, ice ages, and eventually humans. Every chapter builds on the one before it. So the next time you look up at the moon or stand on solid ground, remember you're standing on the product of billions of years of cosmic history. A story written in fire, stone, and water. And that story is still unfolding. Picture the universe 4.6 billion years ago. Our sun was young, barely lit, surrounded not by planets but by a swirling disk of dust, rock, and gas. In that endless cloud, gravity was the master. It pulled small bits together into bigger ones, like snowballs rolling downhill. Over time, those collisions created something extraordinary, a newborn planet. That planet was Earth, but Earth was no paradise. It was a sphere of molten rock, glowing like a furnace. Picture lava stretching as far as the eye could see, with no oceans, no continents, no life. The young planet was a battlefield, bombarded by meteors from space. Each impact released energy greater than every nuclear weapon humans could ever imagine. Then came one of the most dramatic events in our planet's story. A collision with a Mars-sized object scientists call Theia. This wasn't a small hit. It was catastrophic, an impact so powerful it nearly tore Earth apart. Rock and debris exploded into space, circling Earth like a fiery halo. But out of destruction came creation. Those fragments slowly clumped together under gravity, forming the moon. Every time we look at the moon today, we're seeing the scar of Earth's violent childhood. That impact not only gave Earth a satellite, it also tilted our planet's axis, stabilizing the seasons that would one day support life. Without that collision, Earth might have remained a chaotic world, unfit for the story of humanity. Over millions of years, Earth cooled. A thin crust began to form. The fiery chaos was setting the stage for something new. The birth of Earth wasn't a quiet moment, it was a cosmic war. But from that war, the foundation of everything we know was laid. Imagine standing on early Earth, the ground shakes constantly. Lava rivers roar across the surface, glowing red against a pitch-black sky. Asteroids rain down, each one exploding with the force of an atomic bomb. The air, thick with toxic gases, methane, ammonia, carbon dioxide. Breathing was impossible. Living here? Unthinkable. This period, called the Hadeanian, was Earth at its most brutal. Oceans of fire stretched across the surface. Volcanoes erupted without pause, spewing ash and steam into the air. If you could time travel back, you wouldn't see green forests or blue seas, you'd see a glowing, hostile world more like Venus than Earth today, and yet it was this very chaos that shaped the planet. Asteroids carried water and organic compounds. Each violent impact delivered ingredients for the future. Volcanoes released gases that built Earth's first atmosphere. And as the planet slowly cooled, steam condensed, forming the first rain. Now imagine rain falling for thousands of years without stopping. Raindrops sizzling on hot rock, rivers carving into cooling crust, filling massive basins with water. From that endless storm, the first oceans appeared. They were nothing like our oceans now. They were acidic, boiling, and filled with dissolved minerals. Yet they were the cradle of life waiting to happen. It's hard to believe that from such destruction would come beauty. But Earth's hellish beginning was not a mistake, it was a forge. Every blast, every eruption, every flood of lava built the conditions for something miraculous. So when you walk on solid ground or breathe clean air, remember, this comfort was carved out of fire and chaos. At first, Earth's surface was fragile, like thin ice floating on magma. But slowly, something new began to rise: the first continents. Around 4 billion years ago, lighter rocks like granite floated above heavier basalt. These pieces clumped together, forming landmasses. They weren't huge like today's continents. They were small, unstable, constantly breaking apart and reforming. But they were land, and they were different from the oceans that surrounded them. These continents grew into something bigger. The first supercontinent we know of was Vaalbara, about 3 billion years ago. Imagine a single landmass stretching across a young Earth, surrounded by endless ocean. Later, others formed your Kennerland, Rodinia, and eventually the legendary Pangaea, which broke apart into the continents we live on today. But continents weren't just land. They were laboratories of evolution. Shallow seas along their edges created environments where life could thrive. Rivers carried minerals, feeding ecosystems. Mountain ranges formed, changing weather patterns. Without continents, life might never have left the oceans. It was these rising lands that allowed plants and later animals to colonize Earth's surface. Continents are more than geography, they are characters in Earth's story. They drift, collide, and reshape the planet. And their earliest appearances were the stage on which life would take its next steps. Now let's zoom in on those first oceans. They were strange, alien seas, hot, mineral-rich, bubbling with volcanic gases. Along their coasts, volcanoes spewed lava into the water, creating shallow pools filled with chemicals. Here, something extraordinary happened. Simple molecules began to form amino acids, the building blocks of life. Some scientists think lightning storms sparked these reactions. Others point to deep-sea hydrothermal vents, where hot water and minerals created natural chemical factories. Wherever it began, Earth's oceans became a primordial supervast experiment in chemistry. Over millions of years, molecules grew more complex, forming membranes, storing energy, and eventually copying themselves. The first cells were born. Think about that. Every tree, every animal, every human traces back to those tiny bubbles of chemistry in ancient oceans. The coasts of early Earth were wild places, lava hissing as it met water, storms raging overhead. Yet in that chaos, the first whispers of life emerged. Not in silence, but in fire and water. And once life began, there was no stopping it. For hundreds of millions of years, Earth's atmosphere was toxic, no oxygen, only gases deadly to us. Life existed, but it was microscopic and simple. Then something revolutionary happened. Tiny microbes called cyanobacteria discovered a way to use sunlight for energy photosynthesis. As a byproduct, they released oxygen. At first, oxygen built up slowly, reacting with iron in the oceans, creating vast rust-colored deposits we can still see in rocks today. But eventually, oxygen began to fill the atmosphere. This was the Great Oxidation Event, about 2.5 billion years ago. It was both a catastrophe and a miracle. For many microbes, oxygen was poison, and they died in massive numbers. But for the future, oxygen was a gift. It allowed new, more complex life to evolve. Without it, there would be no plants, no animals, no humans. Imagine it, the tiniest organisms, invisible to the naked eye, reshaped the planet more than any asteroid or volcano ever did. They turned Earth into the only known world with breathable air. Every breath you take today is a direct result of those ancient microbes. Without them, this planet would still be a lifeless rock floating in space.